Current. You must be able to explain current strength and its formula I is equal to Q over delta T. 2. Define 1 coulomb and the conventional current direction. 3. Show diagrams for connecting ammeter and voltmeter correctly. 4. Briefly discuss resistance and its role in a circuit. Current is defined as the rate of flow of charge. That is, I is equal to Q over delta T, where I is the current in amps, capital A, Q is the charge in coulomb, capital C, and delta T is the change in time in seconds. Making charge the subject of the formula, we have Q is equal to I delta T. And the unit of charge is a coulomb, the unit of current is an amp, and the unit of time is a second. So we define a coulomb as a charge when the current of 1 amp passes a point in 1 second. Circuit connections. The basic components of a circuit is the electric source, in this case is a battery, the connecting wire, and the load, which is represented by a resistor in this case. In physics, we use conventional current, which means the direction of the current outside the battery is from the positive terminal through the circuit and back to the battery through the negative terminal. If you can follow an unbroken path from the positive terminal of the battery to the negative terminal of the battery, then everything connected along the path is in series with each other. In this case, the battery is in series with the resistor. The instrument we use to measure current is called the ammeter. The ammeter is always connected in series. That is, it must be along the path you want to measure the current. The instrument we use to measure the potential difference is called the voltmeter. And since the voltmeter measures the difference in energy between 2 points, it is connected parallel to the device between which you measure the potential difference. Resistance in an electric circuit acts like a traffic jam for the flow of charge. We define resistance as the opposition to the flow of charge. That is, it creates opposition to the current, making it harder for charge to move freely. Just like a narrow pipe restricts water, high resistance make it difficult or harder for electricity to flow easily. More resistance, the flow of current is difficult. Less resistance, the current can flow easily. Resistance allows to regulate the current flow through different parts of the circuit. You can see that in this, the bulb has a higher resistance than in this path. And you can see that this bulb is brighter than this bulb. So where the resistance is low, the bulb will be brighter than where we have a high resistance. Activity 1. An amount of charge equal to 45 coulombs move past a point in a circuit in 1 second. What is the current in the circuit? Activity 2. Draw a circuit diagram consisting of a cell, a closed switch, a resistor, an emitter, and a voltmeter across the resistor. Show the direction of the current.